Hello and welcome back to PA Academy. This is a continuation on the video series under signal and system. So now we are going to be looking at the continuous time and the discrete time signals. So in illustrating that, we are going to be using the diagram that we have on our screen. So this particular diagram, let's call this diagram A, and let me call this for B. So this is for the continuous time signal. And this is for the discrete time signal. So when we talk about the continuous time signal, okay, so before that, for this amplitude, there are values here. So you can just take note of that. So let me just give you some random value. Let's just call this 1, 2, 3, 4, like that. So on this side also, there are values for the amplitude. Just take note of that. So for the continuous time signal, it's defined for continuous of values of independent variable. Let me come again. It says continuous time signals are defined for a continuous of values of independent variable. Exactly. While for discrete time signals, they are defined only at discrete time. So if you want to explain this further, if you look at it for the continuous time signal, I hope you wrote down the definition. It says they are defined for a continuous of values of independent variable. So you can see that there's a continuous value for each of this time. As I see, there's always a value for it. If you trace it down to the side on the amplitude, for example, between 4 and 6, we have 5. I can easily trace it here and then I bring it here. Exactly. So there's a continuous value when you're talking about the continuous time signal. But on the other hand, when you look at discrete time signal, it says what? Discrete time signals are defined only at discrete times. You can see, so we can only get a defined value of the particular signal at discrete time. That's each of this time here. Exactly. So that is when we can define. We said discrete time signal are defined only at discrete time. Exactly. So it can only be defined only. The continuous time signal is also similar to the analog signal. Exactly. So it's similar to the analog signal, and then this the discrete signal is also similar to the digital signal. So this video will just cover for both the continuous time signal and the analog and digital signal. I hope you're able to get an idea of what the continuous time signal and the discrete time signal is all about, including the analog and the digital. So just take note of the diagram. Exactly that. When you're talking about the continuous time signal, you are going to be having something like this. Exactly. So letting you to know that for every value, for every time, there's always a value for it. Exactly. Why for the discrete time signal, that you can only get a value at discrete time. Exactly. So that's why we are having something like this. You can only get a value at what? At discrete time. All right. So that is what I'll be covering in this video. So in the next video, we are going to be looking at so we've looked at the continuous, we've looked at these two at once. So the next one we're going to be looking at is the periodic and aperiodic signal. We are going to be looking at the difference between the two. All right. So thank you very much. If you find value, if you have any question, don't forget to leave them in the comment section below. And with that, I'll see you all in another video.